Okay, so this is supposed to be the second tutorial from the first section that we've discussed, and I'm just sort of fixing my board so that I can have a white chalk. Okay, so yeah, there, it's perfect. So we've discussed some of the important issues with scalability while we were actually trying to search a string through a pattern of lists, and then we discussed that any algo which actually lets user iterate through n operations isn't really very good. And so after the first tutorial we discussed that we really got to figure out something really better than those number of comparisons, and then just let's think through the problem for some time and see what exactly can actually be done to improve the situation. Yeah, I kind of did give you guys a hint in my last video tutorial. That was pretty much yes, but it wasn't anything that was discussed in detail. So let's go back to the problem statement that we discussed in the first tutorial. And then we were actually looking for a string which was, let's say, A, B, B, C, C. Alright? Okay, so we've discussed one of the iteration techniques, and I'm not going to go back and explain that, so probably you can check the first video tutorial for that. But I'm going to move forward to actually see how we can improve the overall scalability of the logic that we're trying to implement. Okay, so we're trying to search this string, and we've already discussed that there's one way to actually iterate through all of these lists and then figuring out, which is not a very good way to do it. So a better way to do it is actually arranging all the elements of this list in ascending order. So let's say we actually rearranged all these elements from their increasing order. So it's like, yeah, so the element on the topmost left is supposed to be the smallest, and the one on the top right is supposed to be the biggest. So what we can do is we can actually start searching the element from the center. So let's say if the element at the center was A, or let's say it was just AA, sorry about that, A or is kind of stupid. So AABB. So we just discussed that AABB is supposed to be less than AABBCA, right? So we figured out this, the element that we actually had at the center is less than the target string that we're trying to find, and so without even iterating through these indices, I know I'm supposed to actually look forward somewhere in this direction, right? So in the remaining half of the section, let's say again we figured out we're supposed to take the center and saw that the center element was BBCCAA, and then we figured out that this element was greater than the string that we're trying to look for, so we know that the element that we're looking for lies within this range, right? So it's, this way, and so we've actually reduced the comparisons dramatically. What's the scale that we've reduced the comparisons up pretty? So for, let's say if n was 40, so we actually reduce the number of comparisons to 4, which is like approximately log of n order. Yeah, so this seems like a fairly scalable logic to implement, because if the number of elements we sort of increase, it's not increasing the number of iterations or the time scaled through the number of features of elements across it. So yeah, that's really one important part that I wanted to bring into the connection. So scalability of the overall system has been dramatically improved by actually arranging the elements and then sorry about that. So starting the whole of the iteration process from the center and then moving left or right depending upon the depending upon which string is, or which element is bigger or smaller than the element that we're looking or searching for. All right. So, yep, this was pretty much for our second tutorial, and we're going to discuss some other important concepts in scalability and further MapReduce sections down the line. So if you guys have any questions, any comments, any feedbacks, just drop me a message or connect with me, and I'll be more than happy to